Right, so we're back with another update. This one's probably going to be a little hard to explain, but I'll try my best. So basically I've moved the paint system from blueprints over into C++ now, so I've had to refactor a lot of that. But before we had like paint actors, now we have paintable meshes. You need to kind of understand Unreal to understand what that means. But if I just look over here, we've got these old boxes, what we were using before. These were paint actors. So inside these actors, you would have the mesh, which you can see there. And then there was also like a camera inside. So then you would hit the mesh. The paint actor would go, okay, the mesh is just being hit. We're going to unwrap the mesh. So we'd apply like a material to the mesh. We'd paint it, apply like the paint there, take a picture of it, and then wrap it back up. And then the paint will then display on the like mesh afterward. But now it doesn't work like that. Instead, I've actually overridden like the static mesh component and made that a paint actor, so it's got its own kind of functions within it. And then there's kind of like a subsystem that kind of works out in the ether that kind of makes it all work. So it's kind of a little hard to explain, but before we had this kind of long ramp that went all the way down like this with all these were all individual actors. But now this new ramp over here, which is the new painted ramp, so we can't really paint this with the new system. We can paint this one with the new system. These are all like connected together in a single actor. So these are like multiple meshes, but they're all one actor. So you can kind of move these around as one big thing. And they still paint individually, and I'll show that in a minute when I get onto the projectile side of stuff. But I'm just kind of trying to explain the theory behind it all before we get into that. So we'll actually hit the actor with like a raycaster or whatever, or a position, and we'll get that mesh. And then we'll send that mesh and it hits render target, which is like the texture which has the paint on, over into the ether. And then what will happen is it will send this like little probe out, which has a camera and a invisible dummy mesh on it, essentially, into the same location of what you've just hit, and it will rotate and scale accordingly. Then it will apply the paint on the dummy mesh, which is an unwrapped version, so it's like basically like you can only see as if it was like if you got a box and you unfold it so it's flat. That's basically what it sees. It takes a picture of that with the paint splatter on it. And then that, because it's a pointer to the texture, it's then applied to the original mesh. All in that one frame. That mesh is, the dummy mesh is unhidden, the picture's taken, and then it's re-hidden, so you'll never see it basically. But what that means is, I don't have to have a capture on every single model in the entire environment. I've only got one capture for everything. So even if loads of things get hit at the same time, in that one frame, this will be zipping around taking loads of photos. So you'll see that when we're actually hitting like between two like you got two meshes butted up next to each other and you hit on a seam, it will still paint correctly. And there's also like a whole, with how the shader works, there's like a universal kind of world aspect to it that allows the paint splatters to remain consistent even across seams. So I don't know if that makes sense, but I tried my best to explain it. Now, as a result, the ground friction system that I had before is currently not working. Well, it kind of is, but I haven't actually tested to see if it's working because I haven't like integrated it into the character yet. But I had a massive issue trying to figure out how in C++ code, how to like shoot a raycast and detect what color paint was at that pixel on the model. I eventually solved it. I ended up creating my own UV like vertex to UV coordinate conversion thing to get it to work, to then find that I can just use the BP functions anyway in C++. So that was obviously something that I didn't even know about, which should have been obvious, but it just went over my head. But out of stubbornness, I'm going to still use my own UV coordinate conversion because I created it anyway. And if there's any changes that I want to make to it, I can just, I've actually got the raw code there. And if I find there's bugs with it, I can always like lean back on the BP version if I feel like it. So that was a bit of a pain in the ass to get to work, but that wasn't the issue with trying to get like the detection for the color to work. The issue was something to do with reading a specific pixel on the render target. I was using the syntax to read a render target, and for some reason I was always getting black no matter where it was. Even though the coordinate for the UV was correct, I was always getting black even though there were red pixels there. So in the end I used the BP version, which just seems to work, and I don't know if there's some like weird like texture conversion stuff in there where it is able to read it, but whatever. But there is a huge problem with that. The problem is with the BP version, and to be honest with the version I was trying to create, what ends up happening is you'll take the information for the texture from the GPU and then move it over to the CPU to then read it, and that is kind of a slow operation. The way I would get around that is by creating a compute shader so I can get the information from the GPU instead. But the problem is I have literally no idea how to do compute shaders. Like, I've got very little experience with them. I'm willing to learn, but I don't really want to spend all that time at the moment doing that, because it's like an optimization thing. I've basically solved the issue doing it the slow way, and it's still fairly quick. The only problem is probably going to be when I want to read multiple pixels at once. That's where the problem's going to lie, and it's going to slow down. Because basically, like, the GPU and CPU are going to have to be playing catch up with each other. So if I'm just reading it straight from the GPU, it's going to be way faster. But again, it's kind of, I've left the gap there in the code for me to then later fill that. It should be fairly easy to fill it in. It's just working out how compute shaders are, how they work in Unreal, and how I can apply it. So I'll end up spending probably about a week doing that, and I don't want to spend a week now doing that. I'd rather get loads of other stuff in place and just put that on a list of optimizations that I need to do later down the line. Right, so the other thing that I was having an issue with was, for some reason, when I would paint a mesh, it was actually capturing the dummy material. So like, the best way to explain it is what would actually happen. So I'd paint the mesh, and instead of painting the splatter, the entire mesh would kind of get painted, but only like transparently, and it would almost be like checkered. And it was very strange, and I was like, what the hell is going on? And what I found was, when the capture comes over to capture the mesh, only the first instance when the game runs, is it will capture the mesh, the dummy mesh, before it's been unwrapped and before it has any textures applied to it. So it will basically be like a cube which has a checkered default, like a checkered texture over it, because there's no texture on it. So it would actually capture that in the picture and then apply that over the top of like the paint, basically, and it will be like a mixture of like blue and green and red, like a very vague. So you'd end up with like all the different layers of like paint, like kind of intersecting each other, and it'll look really strange. So I ended up fixing that by just delaying. So when the game first runs, the mesh is spawned in, and then the material to unwrap it is applied, and then it's left to do that for a frame, and then it's removed. So when the game first runs, like standing here, this is probably 0, in the world, there is actually a mesh that appears for like one frame, and then it disappears. So that was a bit of a weird bug. It took me a while to try and to actually work out what was going on, and I found what it is I was setting the visibility of the mesh to off while applying the material at the same time. So then what it was doing was waiting until it became visible again to actually apply the material. So I just had to wait for the material to apply and then move and then turn it off, basically. So that was a bit of a crazy one. And that was kind of it for reworking the paint system. So the next step was applying that to projectiles, because before, if you remember, I was just shooting a raycast and then drawing the paint on objects. Now I've started to integrate the projectiles into that, so I'll show that now. Right, so I'm actually in editor now, so it's not as pretty looking. Now the projectiles have like hit events. We've got on bounce, we've got on impact, and then we've got on sleep, but it's basically when the projectile dies. So there's a bounce, and then a second bounce, and then a death. So you'll see, like, I've basically got it set up so at the moment it will paint a small amount when it bounces, and then when it impacts, and then there's a delay, and then it will explode, so to speak. So that's basically what that is. So in here I've basically just got a quick setup for this. So we've got the on impact event, on bounce event, and then on sleep event. So on an impact, we paint at the location, we get like the impact point. Same here and same here, and they've got different brush sizes. That's as simple as it is. And then this channel is like what color. So if I were to change this to green and change this one to blue, and then run this, so we got the different colors now, and then this will paint blue at the end. Well, red technically, but you can see like how this all kind of works with the whole paint system. Right, so those are the 3 events. So over here we've actually got a lot of new changes, and I can't remember which was there before and what are new because I've done so much here. So we've got like a sleep delay and all this kind of stuff. I can't remember if I set this up before. We have instant, which is it will land in the place and then instantly explode and go to sleep basically. Then we have a fixed time, so we can set a fixed time of how long it takes, which is the sleep delay. And then the last one is wait for lifetime first. So if the lifetime's 5 seconds, what it will do is it will hit, and then if I were to set this delay then to 2 seconds, it will wait for it to die first. So if you shot it and it was traveling for 5 seconds but then it hit something, it would only take 2 seconds for it then to go to sleep, which will then call this here. However, if I were to have it unfixed, then it will just use the sleep delay. So the moment it hits something, then there'll be a sleep delay. It will basically clear the lifetime, and then there'll be like a fixed amount. So imagine this is kind of like how a grenade would work, and then this is kind of like how something where it hits on something and it goes beep 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 bang, right? So that's kind of the difference between the two. Outside of that, I've also got now a full speed section. Before we just had an initial value, but now I've got a time curve that we can add in, and we can select the curve. So this is like the initial speed, and then this is the final speed. This is the duration it takes to get to that speed, and then this is the curve that it uses. So we've got a few different curves here. So I'll just demonstrate that. So as you can see, it'll speed up over time. So it starts slow, and then it just speeds up. So if I were to change the curve here, it will basically change how that works. So it's basically just a different kind of distribution of how it will start. Like it will kind of, you'll notice that it speeds up a lot faster. That's because of the curve. If I were to use the other curve, say we've got this kind of central bias. This is for something else, but I'll use this one just to kind of demonstrate. So this will start really slow, and then all of a sudden it will then gain speed. So it will start really slow, and then it'll get to a point where it just starts accelerating really quickly, and then it stops because it then dies. So that's our speed. So I'm going to set this speed now just to like our normal amount, which is this. So this same curve can also be applied to gravity. So gravity, like this is how much gravity we'll have at the end. So if I were to put this at -1, and then the initial value starts at 0, and then over a duration of 3 seconds on a linear curve, we'll then apply gravity. You see how it just goes up into the air? So it's almost like a bubble. It just floats up into the air. So like practical applications of this would be, we would actually have, say this would be like, say 2 seconds, and this would be 1, and then we start, and we kind of have this kind of ease out curve here. So like what you could do with this is you've got drop off on your weapon now, but it doesn't drop off straight away. So you have like a moment of accuracy and then it drops. So that's like over 2 seconds. So if you were like, say we're going to put it over 4 seconds instead. So it retains its kind of airtime a little bit longer. So that obviously adds a lot of flexibility. I can kind of create a lot more like variation in how the projectiles move and everything like that now. Eventually I'll add more to that, maybe like deviation over time and all this kind of stuff, so we can have it move left and right and all that kind of stuff. But at the moment, that's just where I'm going to leave it. I'm not going to go too crazy on it. I just wanted to see what was possible. The other kind of thing that I need to do in the background is, at the moment I'm using the projectile movement component. I actually want to completely remove that and not have to do that, and so I can have full control over it. And what I will need to do is add things like substepping with my physics calculations. Because if you imagine, if something's moving and it's moving at a trajectory where it's kind of dipping downward, there's going to be situations where it won't detect between frames because of the rotational aspect of it. The forward direction's fine, but when you start to get rotation in there, you need substepping. And what substepping kind of is in one frame you do multiple detection, like multiple detection collision checks to kind of get a wider variety of like kind of checking on an angle. Like say if it's aiming at a straight angle straight forward, and then the next frame it's going to be at 45 degrees downward. You need to have like a check in between those to try and like figure out if there's anything in between that angle that might get hit in that frame. So that's all technical mumbo jumbo. Let's move on to the other thing I've been working on. So on the projectile, I'm actually going to set the gravity to 0, and I'm going to keep the speed. And what I'm also going to do to this projectile is I'm actually going to make it small. So if I go here, if I go here, and I make this 0.05 instead, so the projectile's smaller now, so we can properly demonstrate this. So this is our weapon object, so this is kind of the thing that's going to be determining when we shoot the projectiles, right? So there is a little bit of blueprints here, but this I'm going to change a lot. This was just kind of set up temporarily. But a lot of this actually just uses our pull projectile component here. It kind of pulls pulls a actor from here, and then it comes through here, and then it wakes it up, and then it fires it in the set direction and everything. And then if it fails this, it just sends it back into the pool because it's like not the right type of projectile. And then it leaves a little error saying this is not the right type of actor. It's supposed to be a projectile. What the hell are you doing? But this is just kind of a temporary setup for now. In here on the fire event, we actually have a fire rate here. So this kind of only triggers when the fire rate is ready. So we've got like a special struct that has a whole time parameter inside it that determines when the bullet can be shot, and that's what the fire rate does. So we've got an initial fire rate, and this is all that it's set up at the moment. So if I press play and we just shoot this at this wall over here, you'll notice that it just shoots at a fixed rate. I'm going to turn the bounce off in a second so we don't have this, so we can actually see them sticking in place. So I'll just do that. So you'll see this just sticks in the wall. It shoots at a constant fire rate. It's always the same. So if I just go in here now and I quickly change this to 0.01 so it's a lot faster, and then we run this, we'll see now that this just shoots really quickly, and we can kind of spray it. And it just, sprays like crazy. So again, press use curve. We've got these pre-made curves. I've only made 3 at the moment. Linear is just a basic like 0 to 1 linear line. So that's kind of the most basic. So what we can do now is we can set the initial fire rate. So if I set this to like 0.5, and then we can set an ending fire rate, and then we can have a build up time of like 3 seconds, The reset time is over time. So what that means is we've got a few here. So one's none, so it will never reset. It will get up to the speed, and no matter what, it will never reset. So I'll just show that now. So like, it will gradually get faster, and now it's at max. When we stop, it will always be at max. That's basically what none is. I probably will never use that, but I'll just put it there just for the sake of it. So then we've got fixed. So this is a reset delay. So say if after a 1 second of not shooting, it then resets. You'll see at the top there's a little wind up counter, so that when that gets to 1, that's like us at max wind up. So it goes up to 1, and then we release, and then after a second it goes back to 0. So just to see that visually, this is max, and then if I go again, I can do this because we're still at max, and then it will stop, and now it's back to normal. So that you can kind of think of that as like a minigun, but it doesn't have the wind down time. So what we can actually do here is we can set over time. So now we have the reset delay still there, but then we also have a reset time, so it will wind down. So again, it will wind up over those 5 seconds or whatever it is, and then we'll release the second delay, and then it'll start winding down, but we can kind of interrupt it. But you'll see that it just suddenly then starts going really fast, right? So what we could do then is we can apply this curve, which is an ease out curve, to it. And then we press play. And then what this will do is it will make it a bit more gradual. Like, it'll get to the top, and it just has a better feel to it. The issue is you're tied to frame rate as well. There's going to be a maximum speed that you can shoot a projectile, and which is 1 once a frame. So you get to a point where you can't spawn any projectiles any quicker than what you're already doing. And to counteract that, eventually I'll add like shooting multiple projectiles in 1 frame, but I'm not there yet. So to coincide with this, so I'm actually going to set this to a fixed amount, and I'm going to set it at quite a high value so it shoots really quickly. To coincide with this, we've got spread. We've got yaw, which is our horizontal, and pitch, which is our vertical. This isn't completely finished yet because there's no options to turn this on and off at the moment. I've just got it set all to 0. In it, like, eventually I'll put in some kind of enums. So enums are like these kind of options. Like with this one, we've got these drop downs. These are what enums are. So eventually I'll put in some enums here so I can kind of click buttons and open certain things up. So I can just have a fixed spread so it always shoots at a certain amount, and then all the other parameters you can add and whatever. So this is not complete at the moment, but we've got our yaw, which is left and right, and then pitch, which is up and down. Now, I had a lot of problems trying to get this to work initially because the way I was setting the spread, I was having the yaw and the pitch, and then what would happen is you would end up with a square when you're with your spread. Like the corners would be like the extremes, so you would end up with a square. It was hard to explain. I managed to fix that, and then the spread, depending on what distribution curve you would give it, you would have a cross instead. So like it would kind of favor the extremes of the X and Y. Or the yaw and the pitch, and it wouldn't kind of want to go too far into the diagonals. So I ended up messing around with the math for a long time to get it to work, but eventually I managed to get it to work correctly. So this goes up to 90, right? 90 is an insane amount. It's basically like extreme left and extreme right. And then this will be extreme up and extreme down. So it would basically, the direction that you're aiming, it'll shoot either upward or downward, which is a bit of an extreme. So we don't really want to do that. I'm going to put this at 15, which is actually quite a big angle. And then we've got a dead zone, but we'll go into that later. We'll just show this first. So what you'll find is this will just spray like crazy. So you see we're using a linear distribution curve here, so it means that like the distribution of all the projectiles are confined to that circle, and they're just going to be random in that circle. So with this one, this is just going to be like everywhere and everywhere basically in that kind of area. It doesn't really have any like bias or anything, it'll just throw wherever. Then if I were to change the curve to say more like this ease out, it's going to kind of be, you think of this is the center, and then the end of the curve is like the exterior. So what this will do is it will have a bias now toward the outer areas. Kind of start to get like a circle forming around the edge. For something like say a shotgun, is you'd want to use a distribution curve that's a bit more like this, so it kind of congregates more at the center, and then as it gets to the exterior, then it kind of then sweeps up. So you'll see with this one, you'll see that a lot of it is, there's a few ones that kind of hit on the outside, but most of it is staying within the center. So with a shotgun, I'd probably actually make this a bit more shallower toward the center a little bit more, so it kind of, you get a bit more spread, but there is a lot more focus on the center. So the other thing that we have is we've got this dead zone, so I can actually put this up. This is percentage, so if I put this up to 0.5, and what I'm going to do is I'm going to use the linear one, so we can kind of see this a little bit better. So with the dead zone, I probably won't use it much, but I kind of did it just because it's another option that may be useful. But you'll see that when we shoot, there's an area in the center that doesn't actually get hit at all. If, for example, I kind of put the pitch up to 10, so you see like now our spread's more of an oval. So with this we might want a weapon that just shoots in like a horizontal line, and this is kind of what this would do. So at the moment the spread is just set up to be random, but there might be a situation where I want there to be like a very specific pattern, which is something I'm going to set up later on down the line, but for now this is all just randomized. So just like the fire rate, we also have a build-up time, a recovery time, and a recovery delay. So over 5 seconds of shooting the gun, the spread's going to get bigger. And then there's going to be a recovery time of like just a second, and then there's a small delay as well. So then what this will do is it will start very accurate, and then over time it will start to basically become a bit of a mess. And again, this has its own curve, so we've got a build-up curve here. At the moment it's set to linear, so if I were to set it to ease out, this will probably like stop that kind of constant chain of accurate bullets at the start, and kind of the spread kicks in a bit sooner. Obviously this is going to have to be translated into some kind of crosshair so you can see where the actual spread's going to happen. It's going to run really slow because we're painting so much in one go. Like, I probably wouldn't make a weapon that sprays like this, but and that's kind of it for this week. So if you enjoyed, leave a like, leave a comment. Again, over on the Patreon, free members get it a week early, paid members get the videos 2 weeks early. So if you're interested in supporting the project and the channel and whatever, go over there. Even just follow for free, that would be really cool. And if you want to do none of that, would you kindly bugger off?